Hi, welcome to Draw Plans. I'm Tom Norris, and today we're looking at Onshape. Now, Onshape is a fully featured CAD data management collaboration platform. It's available to the hobbyist and maker communities free of charge, but of course you can design anything from a bicycle to a rocket ship on it. So what we're going to do now, it's not we can't download. It's not something you download because it's a cloud platform. So therefore you work, learn and use Onshape whilst online. So let's get over there. What we're going to do is sign up and let's have a look at the tutorials and see if it's going to be of interest to anyone that's interested in learning a bit more about CAD design, manufacture and so on. Right, let's get to it.
Old CAD means that engineers are system administrators and software administrators and hardware administrators. New CAD means engineers can do what they love: design innovative products.
It's not acceptable with this company to not move forward.
If you don't like change, you're not going to be happy here. When something better comes along, we're going to try it.
Old CAD is limited by old technology.
Expensive software running on expensive hardware.
You're spending your time trying to fix the software rather than fixing your design.
Everything is moving to the cloud. And for CAD to not do that just doesn't make any sense.
The more you look at it, the more you realize, do I keep going through this pain, or do I at least try something new?
So a couple years ago, we stumbled upon Onshape and
it was met with some skepticism. I myself was skeptical in the beginning.
A buddy of mine pulled it up on his phone. I thought he had like a viewer up, told me, no, this is the actual model. Look, you can edit.
Finding out that we could use simpler computers and just have the CAD run in an internet browser, that's what really intrigued me at first.
Everyone was kind of thinking the same thing. If this can work, we need to do it.
How we chose to do it was to take one guy, have him go complete Onshape, and see what he thinks after just living in the world of Onshape for a few months.
I was the guinea pig and got to just take a first look at it and see what would be beneficial for our company. It didn't take very long before we were seeing, wow, this tool is really becoming useful.
And after 3 months, he didn't want to go back.
very first time we logged in while driving back from a potential customer visit and designed the first part that we ever did on the phone. And that was just astonishing. That's what sold us. The fact that we can collaborate inside a single document on multiple facets of the design at once. Just because Onshape's a web-based application, don't think that it's not a fully capable CAD package.
A lot of times in other systems, you have to wait for them to finish. Whereas if you're just working on a portion of it, in Onshape you could be working on those in parallel and reducing some of the downtime.
It is incredible the degree to which you're able to compress the time scale of bringing innovations to the market.
To share the ideas and keep those ideas moving, that's the glory of Onshape.
The complexity of designing a snowmobile and really any sort of large project is integrating things properly together.
There are over 1,500 unique parts and over 3,000 repeated parts. So it is a very complex product.
Once we started looking under the hood, that was what really made us think, okay, we got something that we can really work with here.
It allows us to save thousands of dollars per user per year, and that's resources we can put straight back into development. Switching CAD platforms is not comfortable. Onshape made it easy. We took that leap, went full on board with Onshape, and we haven't looked back.
We wanted to get better. We wanted to get faster. We wanted to be more efficient.
What I say to my peers is, go give it a shot. What really drives me as an engineer is I like to create things and come up with new solutions to different problems.
It's a tool that works, makes us competitive, makes us more creative, moves us forward.
Onshape is really allowing us to get back to being what it is that we're passionate about, being engineers.
Now that's what I call a good promo video. What a great intro. It gives you a really overall or a great insight into what the product is all about. I certainly want to know more. So let's get on over and see if we can do a sign up. So we're on to the free, I would imagine. Yeah, let's see if we can get a better insight. Get behind the scenes, so to speak, for someone that's just coming in and trying to get their head around it. Okay, so we're signing up. We're looking basically for the hobbyist, the free bit. See if we can get in and have a look behind the scenes, see what's available. I'm still thinking about that promo. It's pretty exciting, isn't it? I mean, we talk about design and modeling and creating products and so on, but the reality is that's just bloody awesome. Right, so what I want to do now is get my account activated and go straight in and have a look at one of their tutorials, something like Basic CAD. The tutorials are elaborate, they got loads of them, so we're going to take this one, CAD Basics, take the first section of that, Introduction to CAD. It's dynamite, so watch, enjoy.
Life. CAD is used to model and engineer designs, allowing engineers to visualize, test fit, and explore how mechanisms function before prototyping or manufacturing. CAD provides users with an efficient and robust engineering environment to test, design, and implement their ideas. It is used in a vast variety of fields and industries, including automotive, aerospace, architectural design, product design, machine design, and several others. Designing in a CAD system enables engineers and designers to iterate on designs quickly and inexpensively. CAD models can be reviewed, analyzed, and updated, ensuring the design is operational and safe before beginning the prototyping and manufacturing stages. CAD saves resources and cost by reducing errors, miscalculations, and time to market. To better appreciate the advancement of CAD, it's important to look back at how the design process has evolved. The history of CAD is a fascinating story, spanning a nearly 60-year-long timeline and incorporating multiple technological and platform shifts. For a full and excellent narrative, please feel free to browse cadhistory.net. The nutshell version is a story that steps from a completely manual process using drafting boards through some of the earliest software work in relational geometry from people like Ross, Cohen, Sutherland, all the way through to today's distributed software as a service platforms. The early work on hardware and software was largely academic until the mid-60s, when for the first time, the availability of commercial mainframes in the deep pockets of the largest corporations, such as GM, General Dynamics, and others, enabled the application of these technologies to commercial and military purposes. These systems were expensive and primitive by today's standards, largely duplicating the wireframe manual drafting process, and ran on proprietary hardware, but it was a start. By the 1980s, we had the next platform shift, the personal computer and the x86 instruction set chips from Intel. With office computers and the arrival of a certain company, Marin Software Partners, that later became Autodesk, affordable computer-based drafting in 2D became available. In parallel to this migration to the personal computer, another startup successfully married the emerging technology of solid geometry kernels to the Unix desktop workstation. Much of the research was done at Cambridge University, UK, and commercialized by a number of prior companies, including Matra Data Vision, Euclid, and others. The Unix desktop workstation could handle a significantly greater computational workload. The startup in question incorporated in May 1985 as Parametric Technology Corporation, or PTC. And while not the first solid modeler, it did introduce the concept of parametric features, or the formulaic sequential regeneration of a model. The next platform shift was capitalized on by the 1993 incorporation of Winchester Design Systems that later became SolidWorks, and the 1994 commercial release of a product by the same name. This time, the new platform was a standardized interface of the MS Windows operating system and UI development tools that worked across x86 hardware platforms. SolidWorks was also the first large-scale commercial CAD application that made heavy use of off-the-shelf technologies for core capabilities. Parasolid for the kernel functions, and D-Cubed for 2D and 3D constraint solvers. 3D parametric feature-based CAD has become the standard for manufacturing and design companies. As companies rely more and more on these systems to innovate and design, more and more data is generated. To keep all the files protected and revision managed, companies invest in product data management, or PDM, and product lifecycle management, or PLM systems. These systems protect data in a vault, require a check-in, check-out process, and revision manage the designs. They allow companies to track a design from conception through the engineering process, and in the case of lifecycle management, to the end of its life. In large companies, intricate IT networks are installed by CAD administrators to achieve the level of data integrity needed. Manufacturing has become globalized, and the supply chain has significantly expanded. Intellectual property from the CAD system is needed by vendors, suppliers, or shops to manufacture designs. No longer is every aspect of a design manufactured or created in-house. Files have to be emailed and copies of data are made, creating a data disaster. Engineers have trouble understanding which file is the latest revision of the design, which one was sent to the supplier, and left wondering about the security of their data. Many companies operate in this stage today. Following a long stagnation and platform evolution, the explosion of cloud, web, and mobile that grew exponentially since 2005, software as a service and the social web have become the new standard for business-to-business and business-to-consumer interactions. Think about this. When SolidWorks was launched, none of these companies existed. Google, PayPal, Facebook, Amazon Web Services, Salesforce, Snapchat, Uber, or Twitter. The power and accessibility of this new platform, harnessing the cloud, along with its inherent collaborative capabilities, was a huge draw for luminaries like Hirschtick, McEleney, Harris, Lee, Lauer, and Corcoran to build a new CAD offering. Incorporating as Belmont Technologies, later Onshape in 2013, and entering full commercial release in 2015, Onshape capitalized on scalable cloud computing, the advanced data security offered by AWS, and a zero IT footprint to offer a compelling alternative to aging desktop software. With frequent releases and a completely fileless database architecture, today Onshape stands alone as a full cloud professional-grade 3D design and data management platform. The invention of CAD revolutionized the way engineers work and continues to evolve with the power of cloud-based computing, as demonstrated by companies pushing the forefront of technology like Onshape.